Hey guys! So today we're going to be doing some math. It's SL math. Let me clarify that. And we're going to be talking about finding gradients, tangents, normals, and deriving the first derivative using the power rule. Okay, let's start with this question. So let me just demonstrate what a derivative is really quick. So let's say we have this parabola function, right? And we want to see where the vertex is, and we want to see how to draw this graph. If we give you the function, you're not really going to know how to draw the graph. So we use the first derivative to help us find stationary points, possible points of inflection, and yeah. So that's what a derivative is. Now, to derive this derivative, we use the power rule. So the power rule states that if we have something, say a to the power of n, the derivative of a to the power n is n times a to the power of n minus 1. So we're going to use this rule over here in the first example, and yeah, just keep it in mind. So we're going to try to put this equation in more simple terms. We're going to go y equals, and you can use f of x, you can use y, they're all the same thing. These are just different notations to write it in. And we're just going to rephrase this first equation here to make it look more simple. So we're going to start with 2. Square root of x is the same thing as x to the power of half. Then we're going to do minus 3. When x is on the bottom, it's the same thing as x to the power of minus 1. And plus 12. Keep in mind, we're just simply rewriting the first equation in power terms. Now, we are going to find the first derivative, which can be written as this, can be written as this, y prime, f prime of x. So we're going to use the power rules here. So we're going to do half times 2 is 1, x, and we're going to subtract 1 from this one, from the half. So half minus 1 is minus half. Minus, what is minus 1 times minus 3? Positive 3. X minus 1 is minus 2. And 12 has x to the power of 0. 0 times 12 is 0. So the constant is going to disappear. Now, moving on, we still aren't done yet. We don't want to have negative exponents in the derivative. So we're going to do, we know minus makes it go down. So we're going to have 1 over square root of x plus 3 over x to the power of 2. And there we have it. That is our derivative. This is f prime of x. So let me just recap exactly what we did over here. Basically, we started with this equation. We then took each of these and we rewrote it in terms of powers. Oh, yeah. This would be times x to the power of 0, but we don't have that, so we're not going to really use it. Then after we did that, we actually took the derivative of these, and this one ended up disappearing because x is to the power of 0, and when you multiply x to the power of 0 by 12, you get 0. So then, after we did this, we had negative exponents, which are okay, acceptable, but we don't want them in our final derivative. So then we just converted them to our normal, everyday math equation. There you have it. There's the first derivative. Okay, excuse the background noise. I'm not in my usual environment right now. All right, so moving on, we are going to do this little problem that says we are given a line that is y equals 3x squared minus 5x plus 1. And we're asked to find the tangent of f of x at x when x is 1. So let's draw it out just to get a little idea of exactly what's happening over here. So we have this tangent. Okay, we can tell that it's a parabola probably. So I'm just assuming it's parabola because I'm seeing x to the power of 2. Now we have this parabola supposedly. This is not the actual graph, but I just want to show you what a tangent is. So when you want to find the tangent, okay, let's say this is x is 1. This is 1. So at x is 1, we want to find what kind of slope our line has. So this is the slope at x equals 1. At the point, this point, x equals 1. What is the slope of the tangent? Oh, do we have the tangent? It says find tangent, so we don't know if they're talking about the line, or they didn't really say gradient, so I'm assuming it's the line. But we're going to find both just to show you how to do both. So yeah, this is what a tangent to the line is. Now, let us start. So diving in, we're going to start with our line, right? We have our line. We're going to rewrite it over here. Y equals 3x squared minus 5x plus 1. Now, what we're going to do is we're going to find the derivative of this. Why? So we can find the slope at x is equal to 1. So we want to see what the slope is looking like of the tangent. So this is where we're finding the derivative right now. 2 times 3 is 6x. 2 minus 1 is 1. Minus 5x to the power of 1 minus 1 is 0. And the 1 will go away. So this is our first derivative. First derivative. Now, when we want to find the gradient of the tangent, so let's say finding the gradient or slope of the tangent, we're gonna input y equals 1 because we want it at this point. As you can see, if you have this parabola, at this point, the slope is negative. At this point, the slope is positive. So it really differs. So this is the equation you use for all of the different, to find all the different slopes. But when you use different points, you're going to get a different slope. It's like how if you input them in here, if you put in the x, it's not going to give you all the same y. You're going to get different ones. And for example, here would be 0, here's going to be negative, here's going to be positive. So yeah, we're going to find the gradient of the tangent at, let me specify, at x equals 1. Now, let's change this notation to f prime of x. Oh, but we're going to use 1 here instead of x. And we're going to do 6, 1, minus 5. So we're going to get 6 minus 5, which is 1. So this means the slope of the line, let me write this in words, slope of tangent at x equals 1 is 1. So we know the slope. And we also know that, oh, I should just keep this drawing here. Okay, we also know that when we have a tangent, it is a straight line, correct? Let's change the color of this. This is a straight line. So any straight line has the equation mx plus b. And they're not the same x and the same, well, it's not the same y as here, but it has its own equation. That's what I'm trying to say. So we know the slope, and in the equation mx plus b, you need the slope. So we already have m. X, we're gonna leave it as a variable, and we need to find b, right? X and y, oh, x and y are the same. X and y are the same. Let's put them in red, because we have the same ones as the curve, and that's important to remember when you're solving for b. Now, when we're looking at the line of the tangent, we know the line of the tangent is mx plus b is in this form. Now, we know the slope is 1, so we're going to have 1x plus b is y. And let's try to find the y and the x to be able to find b. Because we already have x, which is 1, and we need to find what the y of x is. Now, how do we do that? We input them back in this equation. Let's put finding y of x equals 1. So let's say f of 1 equals 3, 1 squared minus 5, 1 plus 1. Now, we're going to have 1 squared, which is 1, times 3 is 3, minus 5 plus 1. We're going to get 6. Oh, no. Minus 4 plus 3, which is minus 1. Let's double check that. 3 minus 5 is minus 2, plus 1 is minus 1. So that is our y. So our point here is 1 minus 1. So we're not really looking at this point. We're looking at 1 minus 1. We're looking at this point. So this parabola is probably down here somewhere. Anyways, so this is our point. our point is 1 minus 1. Now, if you want to graph that, it's important, but this video isn't about graphing. So now we're going to input what we have. We know our x is 1 and our y is minus 1. So if you do that 1 plus 1, b equals 0. Oh no, b equals minus 2. Great. Now we have our b, and we can finally find the line. T, line of tangent. And we did, we had 1x, so basically x, plus minus 2 equals y. So our equation is y equals x minus 2. And there we go. This is the line of our tangent, if they ask for it. Now, moving on to part 2. Find the normal to f of x at x equals 1. So now we're still in the same problem. So we still have this parabola, and it turns out we have a point out here, 1 minus 1. This is one of our points. So if you just sketch a quick parabola right here, we'd get something like this. Maybe I'm trying to get it on the curve. Okay. Let's pretend like this is good. All right, so this is our 1 minus 1. And now we have our tangent. We have this beautiful straight line, and we know its equation, and we're all good on that. But they asked us to find the normal. Now, a normal is a line that is perpendicular to the tangent at the point of tangency. This is the point of tangency, and we need the normal to be perpendicular to tangent at point of tangency. So this is our point of tangency, 1, 1. Now we're going to draw a perpendicular line there. So it should be perpendicular like this, a little bit like that. Perfect. So we're supposed to have a 90-degree angle here, 90-degree angle here, 90-degree angle here, and 90-degree angle here. They are perpendicular in all the ways. Now, if we want to find a perpendicular line, we do know that the slope is opposite reciprocal. So if our slope is half, the slope of the normal will be minus 2. Opposite reciprocal. So our line of our tangent, we did need to find the line of the tangent, because now we have to find the normal of it. So to find the normal, we take our line of the tangent, which is y equals x minus 2, and we're going to find the normal. So let's say mn. We know our slope is also 1, because 1 over 1 is the same as 1 over 1, but it's going to be minus 1 x plus b. Oh my goodness gracious. What is happening? Okay, so plus b. Now, we have the slope, but as we can see, this pink line over here, this pink line has a different y-intercept. The y-intercept is somewhere around here. If we make this longer, it's going to be the y-intercept. Now, keep that in mind. This line over here has a different y-intercept, which is it's also on the y-axis, obviously, but it's at a different point on the y-axis. It's over here. So that means we don't have the same b over here, and we don't have the same b over here. So we can't use minus 2 as our b. But we do know the slope. We need to find b. Now, keep in mind, we also have the same x and y. Y equals minus x plus b. And we have our x, we just don't have b. So we're going to do the same thing we did over here. We're going to use, 1 minus 1. So minus 1 equals minus 1 plus b. Now we add 1 to both sides. We're going to get 0 equals b. And our line is actually going to be y equals minus x, because we have no b. And yeah, that's basically it. That's how you find normals, tangents, and gradients. Thanks for watching. If you have any questions, feel free to ask me. Bye!